Ladies and gentlemen, welcome back to the live demonstration area, the place to be to see all the revolutionary technologies that are happening. And this morning, we are pleased to welcome back Roctool. Roctool's presentation will highlight innovative molding processes such as heated platens, showcasing a mix of high performance and energy savings. To talk about Roctool's heating technology, we are very pleased to welcome Mathieu, the CEO, and Edouard PHILLIPE, the Composite Business Development Manager of Roctool. Ladies and gentlemen, you can have headsets to have a simultaneous translation in French if you would like. Mesdames et messieurs, vous pouvez prendre des casques pour avoir une traduction simultanée en français si vous souhaitez. And you can ask these gentlemen your questions after the presentation. The demonstration floor is yours, gentlemen.
Thank you very much, Joanna, and good afternoon, everybody. Thanks for spending some time with us. My name is Matt. I'll be co-presenting with Edouard on my left, and Hugo over there will be in charge of running the machine and our system. So for the show this year, maybe before we start the presentation, just a few words about our company. We're a heat and cool provider, so we provide heating systems, induction heating systems, and cooling units. And we also provide engineering services to make heated platens and integrating heating and cooling inside molds. Molds for compression molding, for injection molding, for blow molding. Just as a matter of fact, Roctool, we have about 600 systems installed globally for multiple processing methods for plastics. Plastics, the big plastic world. Means composite, plastics, and so on. We work in the automotive, we work in sports and leisure, in packaging, in multiple fields. And today we will highlight a new approach, new technology, a new design, which is still using our technology about heating and cooling, but this time we're going to heat up a heat platen. We want to make sure that we bring to the industry a flexible and versatile heated platen so that any manufacturer can leverage high heat capability, flexible heating and cooling, and use inserts to place directly on the platen as they have different applications in their factory. We keep hearing the last few years about a lot of the customers we have. They have press machine, great, but sometimes they use oil heating and electrical cartridges. And they have capabilities, but they have this lack of flexibility when they want to heat up fast, or when they want to stop heating, go to lunch, come back and heat again. No, they just leave everything hot because it takes too much time to heat up the hot press or the manufacturing device. That's not okay. I think with the energy consumption as becoming clearly a big topic for all of us, the point is to say, how can I use induction heating when I manufacture parts? When I don't, everything is off and I can, like I said, go to lunch. So before we jump in the demonstration, Edouard will actually introduce the setup, and then we can start molding, and we will present the material, the first material that we're molding.
Thank you, Matt, for this introduction. So we will present you a new standard for composite processing with guaranteed performance. So behind you, you have this classical press machine where you have our new technology, Roctool Induction Dynamic Saver system. So in this heating platen, we have integrated our induction heating technology combined with water cooling circuit. And on the top of this heat platen, we have put an aluminum mold in this case, which is a coaster mold. So we'll have the opportunity to show you the production of this sample during this live demo. With this new technology, we have our classical Roctool equipment. So on the right, you see our induction generators. It's a power equipment. It's a DZ 50 kilowatts. It means that we have 50 kilowatts as power for each side of the mold, of the tool, for the top and for the bottom. And with these induction generators, we have two cooling units. One is dedicated for the mold, for the RIDZ system, with the capability to deliver 100 liters per minute at 20 degrees. And the second is for the cool of the components integrated inside the generators. We have also this interface controller, the RT21, and we manage all the programmation of the cycle with this interface. And you have the two different parts of the mold, the top and the bottom, which are connected separately on the two generators.
So the thermocouples are in the platen, so you have on the screen the temperature, and I think actually you have a close-up where you can see. What's interesting is that right now we're going to go to 250 or 240. We'll ask Hugo, based on the demonstration, maybe a little less. I think we're doing polypropylene?
Yeah, it's 220.
220 C, okay? So the point is to ramp up the heat platen to 220 C, then transfer to this aluminum insert, mold, hold, and then cool down. And we're going to do that in 5 to 6 minutes here at the show. If I was to make multiple parts, okay, what we would do, we would heat the platen, heat the insert, keep the platen as a transition temperature to be ready for the next cycle. Then I just have to heat up my insert so I can expedite and have multiple cycle without having to reheat everything again. Here at the show, obviously we do a one shot by one shot. We're not here to do manufacturing. A demonstration is good enough, okay? So going back to what Edouard was saying, the platen is made out of steel, but the inserts, they can be aluminum, they can be steel, they can be nickel. We don't have limitation then on the insert itself. Okay, so looking at the temperature, oh yeah, it's already going. So let's bring down. Let's talk about the material that we are placing in the tool.
Yeah, for this first demo, we use a non-woven recycled carbon fibers with polypropylene resin supplied by Yuo Company. Yuo Company, the Japanese company. They produce Ayate material. It's a range of non-woven recycled carbon fibers with the interest to have a long fibers between 50 to 100 millimeters to obtain very high performance properties for final parts.
So it's commingled?
It's non-woven, exactly.
Non-woven.
Yeah.
So what's good about this material is very easy to place in the tool. We don't have sometimes the limitation of woven materials that when you have sharp angles. And Yuho provides the material here. We can see I'm going to do this, the material in a raw format. Okay, it's a thermoplastic polypropylene with recycled carbon. And Hugo just placed this in the mold. So think about larger parts. Here we're in a demo zone, okay? But the point is that it doesn't have to be preheated in an oven. It doesn't have to be transferred in a tool. And we're using the raw material that is pre-impregnated directly in the tool, do the full cycle, remove the part, and together we will check if it's fully consolidated, if we have a good surface quality as well. Because the point of having the induction capability is to get the heat speed, the heat level, and to have the resin migrates to the surface, get the good surface finish, and cover all the fibers. Okay, so that's what we're going to demonstrate now. So looking at the power, another point is we're using the full power of our system when we're doing the heat up. But then in between cycle or when we hold, we can dwell. Okay, so let's say you use 100 kilowatts to heat up everything. But then when you dwell, you're going to use 5 to 10 kilowatts to dwell and regulate and keep some temperature in your heat platen. Okay, so a lot less temperature when you're holding. A lot less energy, sorry, when you're holding.
So now we reach 200 degrees in less than 1 minute and 50 seconds. And so, as I explained, we need to stabilize the temperature at 220 degrees to melt the polypropylene inside the material.
Exactly. So, in terms of compatibility, today and for the show, we focus on all thermoplastic solutions only. Okay, but obviously it's a heated platen. Some of you are using thermoset, and we do work with companies also molding thermoset. We thought that thermoplastic, we wanted to highlight for some of the sustainability reasons, because some of them is using recycled carbon, some of them are recycled, some of them even could use a matrix, a resin that is coming for post-consumer recycled resin. So thermoplastic give us also a sustainability tone that we find interesting to combine with our process that is also exploiting the best energy ratio. Okay?
So now we reach the temperature transformation at 240. And so we have a dwell time of 1 minute just to be able to have the transfer of the temperature inside the material. And in the same time, we apply the pressure to consolidate the material. The final thickness of the part is less than 1 millimeter.
So in terms of a technology configuration, here we're about, I think it's 600 millimeters by 400 millimeters, but we can go up to large sizes. As a matter of fact, we recently installed a 2.5 meter by 1.5 meter heat platen. So we have the engineering for this. It's just about scaling, okay? But it would be the same exact configuration. You'd have a power unit, heated platen with inductor inside the tool. So looking at the inductor inside, this is a little montage that we have, which is having inductor inside the mold and with the cooling network. Okay, so think this as a superheated platen, sorry, this way, superheated platen across the platform. And then you have the insert, mold insert that's placed on the platen and would be heated up, okay? As you know, induction is around, induction is safe. It's used in welding, it's used in brazing, it's used in heat treatment, in many fields. What we do at Roctool for 20 years now, so induction for 15 years. And actually, one of our top partners, NREX, just joined forces with us with their equipment. And this combination of knowledge, how to exploit induction, make us with engineering capabilities that we can simulate how to design the induction network based on your part or based on your heat platen dimension before making it. We know how much power we need, what will be the heating time, what will be the cooling time. We can simulate dwell. All of this work is done with 2D, 3D thermal analysis before making the platen, before making a mold. Okay, so that's what Roctool we do with our engineering capability.
So we start the cooling since 1 minute and 20 seconds. We reach for the moment 130 degrees.
So what temperature typically we can demold this material? ATC. Okay, so this material from UHO, polypropylene, non-woven carbon, demolding at ATC, and then we can see the consolidation. I will circulate the sample.
Exactly. The total cycle time is around 6 minutes, so we have around 3 minutes for the heating, 1 for the dwell, and 2 minutes around for the cooling.
Exactly. So obviously here we could do on this dimension, if we were to be a manufacturer of this part, I will show you why we did this little part, we would do multi-cavity tools. We would do multi-cavity tools, so then cycle time per part would be a lot less than this full cycle. So if we had a 4 minutes or 5 minutes or 6 minutes and a 4-cavity tool, we would be 1 to 2 minutes per part in terms of manufacturing speed.
In a few seconds, we can open the press and demo the part.
Then I will circulate this, the time we pull up the other one.
Sure. We can open now. Let's go.
And actually, the cycle after, the cycle we're going to start now, we're going to change material. We want to show you how we can go from one material to the other just by programming and how easy it becomes once you have heating capability. So I just have a question, and maybe you can raise your hand. How many of you process or focus on thermoplastic? That's a 50-50. Oh, that's pretty good. That's pretty good. So I should ask every time, because that's a way to feel the industry, right? About thermoplastic versus thermoset. But that's good. So the time he demolds the part, just want to show you, I'm going to circulate this for those that, maybe I'm not going to circulate this one because then it gets stretchy. But here's the type of mechanical properties you can get with this material, which I find quite surprising. knowing it's a non-woven, you would expect maybe less stiffness, but it's just remarkable the amount of stiffness that you can get from those materials.
Yeah.
Okay.
One of the advantages of this material is also the formability, droppability. So it's why on this part you can have a very different 3D geometry parts. It can be very interesting with this kind of material, also to do not have preheating and to have directly a thermocompression molding system.
What are the type of resins that we can have in non-woven?
Polypropylene.
No, in the different range.
Yeah, we can use. They have from polypropylene, polyamide,
nylon,
yeah, and PEI,
okay. and others,
yeah, and higher temperature.
It's okay, Hugo. It's actually better to show the material because this way you can see the non-woven, and we can pass it along. We also do something at Roctool. You will see like a logo in the middle. But we have noticed something with the ability to drive the resin in the material. If you have texturing on your mold, like a high gloss or low gloss or some patterns, the resin can pick up the decoration. And that could be interesting for some sports and leisure applications, or even for preparing surface before maybe painting. That's also something that we noticed is combining laser texture on the surface of the tool. So as we circulate this part, and again with that material from Yuho, let's go for the second shot.
Yeah, for the second shot.
So very different.
Yeah, exactly. We will use chopped carbon fibers with polypropylene also, supplied by Weissever company. It's a German company. They produce different prepreg fabrics material with different reinforcement, like glass fibers, carbon fibers, natural fibers. And they use the tape impregnated with polypropylene, polyamide, PC resin to produce weave material. But for this demo, we decide to use not a weave, but a chopped carbon fiber that's made from recycled products.
Okay.
And
so it's a tape. It's a tape.
It's a tape, yeah.
And we just place it in the tool.
Exactly. And after the consolidation and during the heating, we will have the flow of the resin and the material to complete the cavity of the mold. So we, for the slide demo, as you see, we put the quantity of the chopped carbon fiber inside.
Let's go.
And we can now close the mold and restart a new cycle.
So talking about energy consumption and comparison, points of comparison with oil heating. The induction, we have the ability to go, in general, for resin families that are from 150 to 250. Okay, it's one resin family. That's what we do at the show. Then we have the 250, 350 family. And then we have 350, 400 plus. Okay, so then we would get in PEEK and some high heat resins. And when you have a heat platen, if you go only and have very limited capabilities, then you become less flexible when you need to get high heat. The induction gives you this ability, because induction can keep going. If we wanted, we can keep going. Then we need to design the platen and the inductor and the cooling, because we know we go high heat. So it would be something that would be designed for it.
One point also interesting with our technology is that we have no limitation in case of temperature. So we have the capability to heat at high temperature to transform thermoplastic composite material like PEEK, PEC, PPS, for example, very simple and with a very short cycle time.
Yes, in terms of also the versatility, Roctool, we can integrate heat and cool inside the mold and put it on a regular platen, right? But sometimes a small batch of production or the ability to quickly switch tools, that's why we came up with this platen, because then once it's set up on the press machine, there can be a back and forth with during manufacturing projects where you can swap inserts and swap tooling inserts.
So we start the second run. We start to heat with also the maximum of power, 50 kilowatt per side. So you see the temperature growing very fast, 160 degrees in less than 1 minute and 40 seconds.
Okay.
As you explained also, we can manage separately the power for the top and for the bottom of the mold and for our IDS system. So the interest is to have finally the same temperature homogeneity on the molding surface. And as you can manage the power on the top and on the bottom separately, we are able to obtain a very homogeneous temperature on the molding surface of the aluminum mold or steel mold, depending on the application, very precise.
We also have some customers that only get one side heating, and on the other side we have a technique for large plates or large tools with the silicon bladder and using the pressure and pull vacuum, and only with the one side heating, which obviously would cut the power need in half, but that's also something that we do supply.
We have also the interest with our IDS solution to combine also different heating era. So we can add in series different IDS system to complete a large surface to transform different application, in fact. So for each era, we have generators dedicated, and we can manage like that different temperature and different process with different and several equipment.
Exactly. So for this one, what is the temperature that we need to reach?
It's quite similar that the previous. It's
the same. So 230?
Yeah, exactly.
Okay.
So we reach this temperature now, and we keep the temperature 1 minute again for the homogeneity of the temperature and the flowing of the chopped carbon fibers inside the cavities.
So we like to call it a dry heating technology because we're not using any fluids to heat up the tools. We're not boiling water or putting oil under pressure at very high heat to go through pipes that go through a mold and to have a, whatever heating that we can get. And then, as we said, the lack of flexibility, everything would stay hot. Even when you're not using your mold, you would not turn off necessarily your oil heating device. So induction, in this case, is very dry and safe. And cooling is just used with ambient temperature water that will circulate through the tool.
We can add also that we can use air to cool slowly the temperature in case of crystallization thermoplastic material. So we can mix water and air during the cooling to have different cooling rundown.
Exactly. So as we come up and before we finish the cooling and demold, are there any questions related to the heat platen or the heat system? No question? We covered everything? So that's good. So let's see on the demolding. And if there's any question about the UHO material, the UHO team is over there and can respond questions, or the weight saver. I see some of the weight saver representative on this tape technology that they have. Please don't hesitate to go reach out.
All the suppliers have also a booth stand on the show, so you can also visit their booth during the event.
Exactly. Actually, the little coaster, we mixed with Saint-Gobain, who's a manufacturer. We made this little part, and that's the one we just mold. And we have this little thing to show also about dimensional stability of what we did. This is done with 3D textile. That's the demonstration from this morning, where we can do a preform and 3D knit materials, so that instead of having a woven, where sometimes it's always tricky to place, it's woven, and then we use the other one as a holder. And obviously, you understand what we're doing this. Then you've got your little phone holder for your desk. We just wanted to make something cute for the show.
This is the final part, similar that's running.
So that's the
live.
chopped carbon, and you can knock that on metal or on a table. Oh, thank you. Thank you. You can see the mechanical properties that are quite surprising, I have to say. So Joanna, I think you had some question.
Yes, I do.
Before we open the press.
Exactly. No other questions from the audience? No? For our two experts? So I have a question. What are the key advantages of this new technology, Mathieu?
So if I have to summarize, I would say as number one, it's a flexible technology because you can have inserts based on your form factor and have a good heating system without having to go through a full heating integration per mold. Number two, I say it's the energy consumption. If we do compare, we outperform oil heating and electrical cartridges, obviously. And number three, I would say it's versatile because in terms of temperature, you can cover thermosetting, you can cover thermoplastic, and in thermoplastic, you can go to high heat thermoplastics. So 300C plus, 350, 400 plus. I would say that.
Great. And another question, is this solution suitable for high temperature applications?
Yes, like I said, we covered this point. Yes, absolutely.
Perfect. Great.
Yeah.
And maybe a final question. Can you explain why you chose this demonstration today?
So we picked that demonstration because I think in the industry, a lot of people were focused on our technology to be integrated in molds. And it still makes sense for many applications. But for this particular demonstration, we wanted to show kind of having a good base heating system that allows any laboratory, any manufacturer to have a flexible way of removing inserts using not too thick aluminum inserts that gives them also the cost effectiveness in using this process.
Okay, great. So
the final one is in the bottom of the cavity. It's coming out.
The part inside the cavity, so we demold the part with hair.
Okay, well, that's the one we circulated. It happens. That's a demonstration, and anybody making composites, you know it's not that easy sometimes.
Yeah.
But
these are the joys of
so far so good on the demolding.
Live.
It will take some time to remove that one, maybe. Well, thank you for your attention and spending half an hour together. Thank you very much.
Thank you so much, gentlemen. And Roctool will be back today at 4:15. Don't hesitate to come down to speak with them directly or to go across and meet all of the Roctool stand there just right next door here, ladies and gentlemen. And our next, don't hesitate to come back today at 2 o'clock. We will have our next demonstration with Thermwood, who are going to show us why their large-scale additive manufacturing machine is a game changer in additive manufacturing. So thank you so much, ladies and gentlemen. Enjoy your lunch and enjoy your day at the show.